to determine the interval in which the function decreases, increases, or remains constant, we want to take a look at the graph. And so here we have this nice parabola. Looks pretty cool. I'll zoom in a little more. So we want to determine what intervals make this graph increase, decrease, or remain constant. So what that means is what makes the graph go up and down. And when does it go up and down? Which parts does it go up and down? I'll explain right now. So we want to determine when there's a change. So we'll plot a point in which the graph changes from one direction to another direction. And what I like to do personally is draw a line down the middle, because Banana Joe likes to keep it smooth. And so when we answer these types of questions, we want to start off with where the left side of the graph is going. So right here, we can conclude that the left side of the graph has started from negative infinity, because there's no stoppage here. Like, there's no point where it stops. So Banana Joe's gonna put negative infinity, and then we'll put it to where the direction starts to change at -2. Now, how do we answer the other part of this answer? Bro, I'm actually so trash at this. Wait, hang on. Now that we plotted where the graph changes in direction, let's solve it. So, reading from left to right, we can determine that it starts with negative infinity. And what we also notice, thank you for the support, is that it continues to keep going towards negative infinity until it stops at this point, which is what? Banana Joe says -2. Now, you might be thinking, Banana Joe, which -2 is it? The one on the y-axis or the one on the x-axis? Banana Joe tells you it is the one on the x-axis, because we are looking for the domain of this whole thing, of the whole shebang. So now, we have to answer this in 2 points, because it's not only the left side of the graph, but the right side as well. And judging from what we've seen, the left side seems to go down. So we'll draw an arrow going down, meaning it's decreasing. Pretty cool, right? Not the best arrow drawer, but we'll improve. So now with the second point, we start off where we left off at a whopping -2. And then reading the right side of the graph and judging with our elite math student skills, where would the graph go from there? Infinity. What a smart young man you are, or woman. So we conclude that after it decreases from negative infinity to -2, it starts to increase from -2 onwards towards infinity. Picking up what I'm slipping on? Banana joke. Now on to number 2. We have a little different graph. I want to know what to call this graph, because Banana Joe did not pass high school, but who cares, you know? So we're going to plot the point in which the graph changes, and again, I'll draw a line down the middle to highlight where exactly that change happened. And so Banana Joe, again, reads from left to right, so we notice that it's been going up. And now you might be thinking, wait, it started from the bottom though, so wouldn't it be negative infinity? No, it wouldn't. It would actually be positive infinity, because it's going up all the way towards 1. And now we do the same thing like we did last time. Pick up where we left off at 1, and then you might be thinking, what could this possibly be? Infinity? Negative infinity? I say it's infinity. Banana Joe says that because it's above the domain in which the x-axis is positive, so why would it be negative? From that, we can conclude that from the left side of the graph increases, and from the right side of the graph actually remains constant. Something we haven't seen yet until now, which is pretty cool. Our third problem. Here we have what seems to be a pretty wonky graph. Nothing Banana Joe can't do though. So again, we'll plot our point, and then we'll write down the answer already, because there's no line, there's no change in the graph. We can tell that it's going one way forever. So we can start from where it left off, -2. So we'll write -2 onto infinity. Pretty cool, right? I would like to think so. Not Joe likes math. Whew. So far, we've been slipping into a lot of awesome things. And with this third problem, is it constant? No. It's actually increasing. Because it ever so slightly goes up. And it's going to keep going up. You know what I mean? Like my money. On to the next three problems. Number 4. Now you might be thinking, how the heck am I going to graph this? How am I going to answer this? You don't need to. Nah, I'm playing, you do. Banana Joe's going to plot the points in which the graph changes, and there's 2 of them. So what does that mean? You got to plot 3 different answers. So we'll start from left to right. Again, nothing changed. We're reading it just like usual. So we can determine, or we can conclude that it's going up. So we can put infinity up until 0. That's our first part of the answer. That's this part. Second part, you see the graph actually goes down. So we want to put negative. No, you really thought, huh? You're gonna put 0 until what? Is it going down forever? No, it's not. It's only going down to 2. 0, 2. But we do know it's going down. And then the third part of the graph, the part in which it seems like it's going forever, we start at negative 2 and then it goes all the way up to infinity. It's pretty sick. So now we can plot the directions in which these intervals go. Infinite, decreasing, increasing. Didn't mean to say infinite back there, but that's how you do it. Problem number 5. This one looks pretty easy. There's only 2 parts of the graph. It just looks a little different. This part of the graph looks pretty easy. There's only 2 sides of it. So we can still read from left to right. I notice it's going from negative. Nope. It's actually going from positive infinite. Oh my gosh. I can tell that this graph is the same like any other graph, specifically the parabola. So I'm just going to get the plotting. So we can tell that it's going up. So I'm going to put infinity up until what seems to be 0. And then same with this side. I start where I left off at 0 onto negative infinity. Now, you might be thinking, there's a horizontal asymptote. It's not going to go down forever. But it is. It's going to keep going down, but it won't touch 0. So, although the change is very small, you can tell that it's decreasing more and more. Because Banana Joe said so. Problem number 6. Here I'll plot. Actually, no, we'll skip problem number 6. That's kind of hard. Problem number 7. Here we have another parabola, but it's upside down. So what am I going to do? Same thing I always did. Plot my point, highlight the line in which it splits off in directions, and start plotting. Here we can tell that it's been going up. So we can put infinity up until where it stops in direction, which is about 4. Rinse and repeat. You got 4, which is where the direction starts to change, on to negative infinity. How do I zoom out? This is how you do Algebra 3. And this was Banana Joe, the awesomest stream ever. Thank you guys for watching. I appreciate all your time, and your support, and your dedication for watching my very trash stream. That's it. That's literally it. Now I'm going to edit it and make it look professional. I don't know. I could have done a lot of things better. Chat's kind of dead too. I think I'm watching myself. Hello? 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 Well, I don't think anyone's here, so I'm gonna redo it again. Yank. Only you. I wanna go to heaven. I wanna go to heaven. Do you wanna go? Oh. Okay. There's a place for us. Okay, want to restart it? Because it's just me in chat, so I'm not really tripping out. What is up, Banana Republic? It's your boy Banana Joe 808 back here with another math tutorial. Today we have something very special. Something that a lot of people might say would be your help in a time of need. Banana Joe is finally reviewing 2.2 more on functions in their graphs. Are you an elite math student who disappointed your teacher? Well, have no fear. Banana Joe is here. Let's get straight into it. What are we going to do, Banana Joe? We're going to use the following graphs to determine the interval in which the function increases, decreases, or remains constant, if there is any constants. So let's get straight into it. I'll explain it as I go so it makes sense. I'm going to plot my point here in which the direction of the graph changes. Why? Because we need to. We need to find out the intervals in which the graph changes. So I like to highlight a line straight down where it changes. Reading graphs from left to right is hopefully the thing everyone's been doing, because I'm doing that too. And so we can tell that our graph has been going from negative infinity all the way down to this point of negative 2. Using our elite math student skills, we are able to graph our answer as negative infinity, negative 2. Now wait, are we done? Not yet. Banana Joe's gonna slip into some more math. You get? What the heck? I'm gonna blur that out. Okay. What are we? Oh wait. What are we gonna? Wait. Now that we left. Now that wait. Now that we read the left side of the graph, we gotta plot the right. Wait. Now that we plotted the left side of the graph. Wait. Now that we found the intervals of the left side, let's find the intervals on the right side. We notice that the graph, reading from left to right, starts to increase onto infinity, starting at negative 2. So we'll pick up where we left off at negative 2 onto infinity. Pretty simple, right? Question number 2. You got this wonky graph. Banana Joe forgot what it was called. Banana Joe doesn't know a lot, but he does know how to throw math down. That was so bad. That is how you use the following graph to determine the interval in which functions increase or decrease. Now let's get into some constants. Here again, I will plot the point in which my graph changes directions, and I'll highlight a line down the middle, just to aid me. Here Banana Joe recognizes, reading from left to right, the graph is going up. So we can write our answer as infinity 1, because that is where it stops, over here. Now you might be wondering, why isn't it 2? We use the x-axis, not the y-axis. Banana Joe believes in domains. And so we pick up where we left off at 1, and then we plot infinity. Now you might be thinking, Banana Joe, why are you so handsome and right? Bananas, please, please. We say this is infinite because it's going on forever. Not up like this one, but constant. Question number 3. We got something a little different here. Now I'm just going to plot the point in which the direction changes.